Hello, this is the Geographysical, and today I'm going to attempt to explain the drainage basin hydrological cycle. So first off, the drainage basin is the area which is drained by a river and its tributaries, defined by a watershed which marks the boundary between two separate basins. Drainage basins are open systems, meaning they receive both inputs and outputs. Thankfully, there's only one input you need to learn, and that's precipitation, such as rain, snow, hail, all falling into the catchment area of the basin. The water will then flow downstream, beginning at the source and joined by smaller tributaries, creating a confluence, before finally flowing out to sea at the mouth. And this flow, the channel flow, is actually the first of 10 types of flow in the cycle. Second, we've got surface runoff, or overland flow. Pretty self-explanatory, just any water flowing over the land where it can't infiltrate. Infiltration being the next flow, where water soaks into the soil. The rate at which infiltration occurs, however, can be affected by soil type and saturation. Once in the soil, the water can transport by throughflow, which moves downhill, going fastest at points with cracks. The water can then percolate, similar to infiltration, but from the soil down into the water table, at which point it can travel as interflow through permeable rock above the water table, or groundwater flow, which is the slowest flow, through permeable rock below the water table. Once it reaches the river, the water then feeds into the channel through the banks and beds by base flow. Before reaching the ground, water can also travel by throughfall, where water drips from one leaf to another, or stem flow, where water, unsurprisingly, runs down the stem or branches of a plant. This leads us on to water stored in the cycle, through interception, as rain falls on vegetation, buildings, or roads before reaching the soil, vegetation storage, where plants take up water, surface storage in puddles, ponds, and lakes, or water can be stored in the soil or rocks as groundwater storage, with the water table marking the top of the zone of saturation, below which the rocks are full of water, creating aquifers. Finally, and most obviously, we have the channel storage. And to complete the cycle, we've got the outputs, which consist of evaporation, as water in the channel or on the land turns from liquid to gas, transpiration, being the evaporation of water from plant leaves, evapotranspiration, being the combo of both, and river discharge from the mouth. The amount of water stored in the soil at any one point in time can be calculated by using this equation, with P representing precipitation, Q the runoff or stream flow, E being evapotranspiration, and S representing the storage of water in the system. This equation can then be rearranged to calculate the change in storage, or the water balance or water budget graph can be used to see them. The UK water balance shows seasonal patterns, with precipitation, the blue line, exceeding evapotranspiration, the red line, in the wet season, creating a water surplus. And then in the drier months, evapotranspiration exceeds precipitation, causing the ground store to deplete. Then as you move once more into the wet season, the ground storage begins to recharge, completing the cycle. And that about sums up the hydrological cycle. Thanks for listening.